Next we'll see from alkynes. It's similar to that of alkenes only. For example, suppose if I take here CH3C triple bond CH, that is your propyne if I take it, and if I take here bromine, okay, so if I take here bromine, so hence what you will be getting it, that is simply an addition product you will be getting it, CH3C, here Br is being added, here double bond CH and another Br comes in its place. Now here I will give an information to you. If you take here liquid bromine, remember it, listen carefully, if you take a liquid bromine, then you will get a tetrabromo derivative. Tetrabromo means one more step the reaction is going to take place. Here one bromine is added, here one bromine is added. You will be getting a tetrabromo derivative. If you take bromine water, then you will be getting dibromo derivatives, which I have written it here. If I take bromine water, this is your aqueous bromine, remember it. If I take aqueous bromine, then you will be getting this. But if I take liquid bromine, again I repeat, you will be getting tetrabromo derivative. That means one more step I will be getting it, and you will be getting the bromine is added and double bond is converted to single bond and H atom is being removed. That is from alkynes, you must remember it. Next we will see from alcohols. We will see from alcohols. So that is alcohol, that is here what you can say is that primary alcohol is there, secondary alcohol is there, and tertiary alcohol is there. So the reaction is, general reaction is that ROH plus HX in presence of any dehydrating agent. In presence of any dehydrating agent, what it will give you? It will give you RX plus water. Again, it is a substitution reaction. You can see that. So now you will be getting this. But here again 3° alcohol is more reactive than 2° is more reactive than 1°. We can say that. 3° alcohol is more reactive than 2° is more reactive than 1°. So this particular reaction, that is for 2° and 1° alcohol, listen carefully, for 2° and 1° alcohol, the preparation of alkyl halides from 2° and 1° alcohol, the name of the process is known as Grove's process. It is said to be as Grove's, G-R-O-V-E apostrophe S-V-E apostrophe S. This is Grove's process. From Grove's process. So what is the dehydrating agent we will be taking it? For example, suppose if I do from CH3CH2OH plus if I take HCl, and here I will be taking here anhydrous ZnCl2. I will be taking it here. Now why it is anhydrous ZnCl2? Anhydrous ZnCl2 first of all acts as a dehydrating agent. Point number 1. Point number 2. Anhydrous ZnCl2, that is zinc chloride, is a Lewis acid. It's a Lewis acid. It helps in the cleavage of carbon-oxygen bond. This particular bond, it helps in the cleavage of this carbon-oxygen bond. And hence, for that particular purpose, this cleavage takes place easily. Why? Because what I said is Lewis acid. So it will take a pair of electrons from oxygen, and hence it will help in the cleavage of this carbon-oxygen bond. Due to which, in this place, Cl will come and take its place, and water will be released. So let me complete the reaction so that you will come to know CH3CH2Cl plus water. Again I repeat, anhydrous ZnCl2 acts as a dehydrating agent, as I have written it here. Apart from that, it acts as a Lewis acid. Lewis acid means it will pull out the electron from oxygen. When it will pull out the electron from oxygen, it helps in the cleavage of this carbon-oxygen bond. So when this carbon-oxygen bond it breaks, in place of that, Cl comes and takes its place, and hence water is being released, we can say that. So this is with primary alcohol. If I do the same reaction with secondary alcohol, we can say that the reaction is similar, that is anhydrous ZnCl2, you will be getting CH3 CHCl single bond CH3 plus water, you will be getting it, as you can see it here. Similar sort of, so it is called Grove's process. Now with tertiary, as I said you earlier only, the tertiary alcohol is more reactive than secondary, is more reactive than primary, as I said you earlier. So in that case, in tertiary we will see what is going to happen. In tertiary alcohol, as I said, it is more reactive. Let me write it down. Tertiary alcohol CH3, here it is CH3OH, I have taken tertiary butyl alcohol plus HCl, I have taken it. So here conc HCl will do. Here anhydrous ZnCl2 is not required because tertiary alcohol is so reactive, so highly reactive. For that purpose, conc HCl is sufficient. That is to remove the OH group, and in place of that, Cl will come and take its place. So we'll be getting CH3, here it is Cl plus water. Here anhydrous ZnCl2, that is your dehydrating agent is not required because tertiary alcohol is highly reactive. So it reacts with conc HCl. The conc HCl it reacts, it removes, that is a water molecule, and as a result water is being removed and we get that is tertiary alkyl halide, we get it. This is from tertiary alcohol, we can say that. In this way you can prepare it. So with HCl we got it. Now remember it, if I do the reaction with HBr, then we have to go for refluxation with HBr and HI. That is, let us say I am taking here CH3CH2OH plus HBr. So if I am taking HBr, then I have to take, that is KBr along with H2SO4. I have to take it KBr along with H2SO4 because KBr when it reacts with H2SO4, of course conc, this one is, you will be getting it KHSO4 plus HBr, as you can see it here, KHSO4 and HBr. So what you can say is that we have to go for refluxation. That means this reaction has to prepare in C2, this one. So hence what you will be getting it, CH3 CH2Br plus, that is water. So in this way we have to prepare it. Suppose if I take it here HI, if I want that is an iodized product. So hence what I have to do is that CH3CH2OH plus HI, if I am taking it, then I have to use Ki plus H3PO4, we can say H3PO4. Here I will be using it, not H2SO4, I will be taking H3PO4. Here also I am leaving a question to you that why here H2SO4 is not used, why H3PO4 is used. I am leaving a question, I will tell you after this reaction. Let me complete the reaction. So CH3CH2I plus, what is that, CH3CH2I plus water, you will be getting, that is nothing but here this water you will be getting it here. Yes, CH3CH2I plus water you will be getting it. So what I said you, why I have taken H3PO4 not H2SO4, because H2SO4 what it does is that it acts also an oxidizing agent, this particular one. So it will be further oxidized. For that reason I am taking H3PO4, which is a mild that is oxidizing agent, we can say that H3PO4. Alright, so hence I don't use here, for HI we don't use Ki plus H2SO4, we use Ki plus H3PO4, because what I said you, H2SO4 it acts as an oxidizing agent, it will further oxidize, we can say that. Clear? Because you can see in this way, that is from alcohols we can prepare it in this particular way. So this much about your alcohol. Thank you.